So, hello everyone, welcome to the class of Prism. Let's see, this is Prism. What is Prism and how to do it? Let's see. So, Prism is something like this, right? You have seen the Prism. This is Prism surface is like this, okay? This is Prism, okay? I'm just taking the outer surface of the Prism. It may be like this also, right? You can say Prism is like this. So, we are just taking the outer surface of Prism, okay? We are just taking the outer surface of the prism. So let's say we are considering the top cross section of the prism. This is the, let's say like, this is the prism, right? So let's say light is coming here. A white light is coming here. So in prism, this is known as prism angle A, right? This is known as prism angle A. So let's say a white light is coming, and you all know that white light is made up of Vibgyor. So basically, white light has 7 different wavelengths. 7 different wavelengths. Let's try to understand. This is the, let's say this is normal. So angle of incidence is same for everything, right? And so I'll just consider one. Let's first consider one simple simple ray. It's not necessary that this is white light. It will be monochromatic light. Let's say it is a monochromatic light. I'm taking a monochromatic light matlab it is single color. Let's say first let's consider it is a monochromatic light. Since white light has 7 colors, so it will be 7 chromatic, right? You can say heptochromatic, you can say. So monochromatic matlab any single color. Let's say this is coming here. So what will happen? Process I want to explain you. This will be normal here. Ideally it should go this way, but it will bend because it is coming from rarer to denser, so it will bend towards the normal. This is normal, so it will come this way. Here it will reach, this will be normal, it should go like this, but because it is coming from denser to rarer, so it will bend away from the normal, and this will be emergent ray. This will be your emergent ray. Okay. What is happening? Emergent ray, right? So similarly, if your white light is coming here, so what will happen? Let's say this is the angle of incidence. So angle of incidence will be same for all the 7 different wavelengths. We all know that sine I upon sine R is equal to refractive index of the medium in which it is going, right? So I will simply say ki, let's say outside you have, uh, uh, what do you say? Let's say outside you have rarer medium, right? Or it's simply vacuum. So what do we say? Refractive index of the light in which it is going, that is mu 2 upon mu 1, like this, right? So what happens? Mu, I think, let me check it. Guys. Mu 2 upon v1 or mu 1 upon mu 2? I'll simply say it is a Snell's law. Okay, so it's correct, right? Mu 2 upon mu 1. I don't know why I got confused. Okay, so this is this one. So let's say outside you have air, right? Vacuum. So it will be simply mu, which will be c upon v. I have told you already, right? Speed of light in the vacuum upon speed of light in the medium. So it will become C upon V matlab we can say F lambda. And since all the seven colors have been generated by white light means by same source, so frequency will be same for everything, C will be same for everything, and incidence angle will be same for everything. So if we write sine I upon sine R is equal to C upon F lambda, so this is constant, this is constant, this is constant. From here you can say sine R is directly proportional to lambda. And we all know that when we travel from violet to red, lambda increases. It means when we travel from violet to red, angle of refraction will increase. It means since we know that lambda of red is greater than lambda of violet light, so therefore refracted angle for red will be greater than refractive angle for violet. So red light will deviate more. Red light will deviate more, and violet light will deviate least, right? Light will deviate least. So basically what will happen, ideally this should go this way, so this will be, there will be seven different colors will be found like this. तीन दो पाँच 6 7 like this. There will be seven different colors. So which one will be deviated most? The most deviated will be red lights. So this will be red, this will be violet, this will be I, this will be B, this will be G, this will be Y, this will be O, and this will be your R, right? So this white light will be, what we say, it will be dispersed into the seven constituent colors. This phenomenon is known as dispersion, which you will study later. Now you can just understand prism does this. Matlab prism, basically what is the function of prism? Prism, what does it do? It disperse all the seven lights, all seven monochromatic colors from the white light. Now we have to study this functioning, right? So I will simply write, let us just try to understand. Let's say this is prism. Let's say this is prism here. Okay, this is prism here. And let's say this is the light incident here. Okay, this is the normal. This is the angle of incidence. So let's say it should go here, but it is going this way. It should go like this, but this is normal and it is going like this way. So this is angle of incidence and this is the angle of emergent, right? This is angle of emergent. This is the angle of refraction, first angle. This is R1, and let's say this is your you are taking it inside like this one, and this is the emergent ray. So this is actually E, this is E. So this is incidence angle, matlab with respect to, I will say, this is R1 the refractive angle, this emergent ray is the refracted angle. So here this is the light with normal, this is making this angle. I think this is something I have written wrong. Yes, I have drawn wrong, just let me correct it. Let's take out. See, this is the okay, this is the prism. Okay, let's say this is your incident ray. This is your normal. This should be the ideal path, but this is the angle of incidence. The light is going this way. So this will be your angle of refraction. Now this is making an angle of incidence. Let's say this is R2. R2 is the angle of incidence at the second surface. So it should go this way, but it will go this way, and this will be your angle of emergent. Okay? Yes. So I was just saying this will be, let's say your okay. This is your angle of A. This is your prism angle. A is your prism angle. Prism angle. It is very useful in the Fresnel's by prism, right? Chalo. So what do we say? We have to just understand one by one. So you need to derivation you can do at home. First thing is that A is equal to R1 plus R2. A is equal to R1 plus R2. By different calculations you can prove it. We can also prove it, but it's not needed. We will not be doing proving. We're just simply calculating it. So let's say the light was initially going here, and finally it is going here. So if we extend it further, so we can say this is the angle of deviation, right? This is the angle. Well, light was going this direction. Light was going in this direction, and it has gone in this direction. So means this is the angle of deviation, na? Delta. Correct. So delta, how to calculate? If you find delta, so delta is basically, you can say I plus E minus R1 plus R2, right? R1 plus R2. See, let me just draw it. I'll try to give you something. Let's say this is this one. So delta is basically, we calculate it. I'm trying to calculate, but it will be difficult. So this is delta. So delta will be sum of internal these two angles, right? 180 minus this one. So we need to calculate delta R1 plus R2 minus this. I plus E minus R1 plus R2. And R1 plus R2 is A. So we can write delta is equal to I. Guys, proving I'm not focusing because it will take time. Drawing is also taking difficult, right? I plus E minus A. For proving, you can refer book. This is the formula, right? Now there is a principle of reversibility of light. Principle of reversibility of light says that whatever will be the light, if the light is going in one direction, if the in the same direction you want to send the light from the reverse direction, then it will follow the same path. Matlab, if the light is going in this direction, and if the light is source is here, then it will follow. If it is following this path, then if the source you are putting here, then also it will follow the same path. So this is the principle of reversibility of light, and this says by this we have observed that deviation will be minimum. Deviation will be minimum if I is equal to E. So we write delta minimum. We write delta minimum एक मिनट क्या what is happening? What is happening is एक मिनट delta minimum is, I'm not able to write, just एक मिनट. Delta minimum So do your एक मिनट just एक मिनट. So your minimum is equal to I plus I minus A. So it will be basically 2I minus A. Okay, delta minimum is equal to 2I minus A. So just remember this formula, like delta minimum is equal to 2I minus A. So guys, try to understand from here. This is another formula, right? This is another formula. So from here, can you say that I is equal to delta minimum plus A plus A upon 2, right? And for, see, for minimum deviation, R1 should be equal to R2. If I will be equal to E, then R1 will be equal to R2. So you can say A is equal to R, let's say both are equal to R, so R1 plus R2 means it will be 2R, and we can say R is equal to A by 2. And Snell's law says that mu is equal to sine I upon sine R, that is refractive index of prism, sine R. So we can say that mu is equal to sine I matlab A plus delta minimum by 2 upon sine R, and R is A by 2. So this is your formula. So what we got? We got few formulas like delta minimum is equal to 2I minus A, refractive index of the prism is equal to sine A plus delta minimum by 2 upon sine A by 2. Third formula we got delta is equal to I plus E minus R1 plus R2. Fourth we got A is equal to R1 plus R2. So these are the basic things in the form of, you can say, prism, right? Guys, based on this, there are so many questions available, right? There are so many questions available on particular first two formula, right? Just remember this thing and try to solve the question. And in the next class, we'll be doing dispersion. Thank you. Bye bye.